Hello everyone. Today we are going to learn SAP 2000 version 21 and we will move to a tutorial. This is introductory tutorial. This tutorial will give you basic ideas about SAP 2000. So let's move into the tutorial. First you have to go to the file menu, then if you want to start a new model you have to click file, new model, then you can click on the blank one, otherwise you can use any other template which you need, but now we are going to select the blank model. Here you can see that there are two windows. First one is 3D view, other one is also 3D view. You can change as you need by clicking here. You can take XY plane view here and 3D view here. That will be more useful when you are doing the model. So to start a model we need reference lines. For that purpose we will have a grid in this window. To form a grid we have to right click here and you have to click edit grid data, and you have to click modify show system. So I am going to model a building, a small 3-story building today. So along the X grid the spacing will be around we will take it as 6 meters, and along the Y grid we will take 8 meters spacing, and the height of the height difference of the two levels we will take as 3 meters. So here to add grid data we have to click add and we will name it as grid 1, and grid 2 spacing is 8 meters, grid 3 16, grid 4 24, and grid 5 we will take it as 32. Then we will move to the grid Y and we will take here again the same measurement for the grid Y also. We will take 8 meters and we will have 3 more grids in Y grid, Y direction, and we will take the building height as 3 meters for each floor, and the level 1 we will have 3 meter height, level 2 have 6 meter, level 3 will have 9 meters. So now we have defined all the grid data. You have to simply select here and type anything you need to change it. Okay, then our grid is complete. Click OK, and you can see the grid is here. Okay, the next step is define the materials for columns and beams. So first we need to define concrete material. We'll go to add new material region we will select as Europe, and material type we will take as concrete. Standard is Eurocode, and the grade we will select as grade 30 concrete. Okay, and we will define the column and beam sections using section properties, frame sections. We'll go to that new property, select concrete, type is rectangular. We'll define the beam as 600 by 400, and the depth width 0.6 and width is 0.4. And more importantly, you have to select the material which you have earlier defined, otherwise the model will be wrong. Click OK. Then again a new property, you can define the column sections. The material is concrete, section is rectangular. Column size we will take it as 500 by 400. Now remember here the depth measurement should be taken as the highest one from these two. So when you are modeling, remember to do that. The depth should be always the highest dimension, and the material is selected as grade 30 concrete. Here the M33 is the moment around major axis, and the M22 around moment around this axis is the minor axis for the column. Okay, now we are going to draw our columns. For that we have to select Accessor plane, and when you select that plane you can see the right hand side in the 3D view. The active window is in here in blue color, as you can see. Now there is active window, that is y equal to 0 plane. So now here we are going to draw our columns. For that we will select draw frame cable, we select that. Here the section selected is beams, so we will select column section C 500 400. Then you click on here and click on here. If you don't click in somewhere here, if you click somewhere here, then the column will go somewhere here, no? Due to that we will right click in here on the mouse to finish this column, and come here again and do click here and right click again, and like this we will draw the columns. You have to do right click to remove the cursor, again click here and again right click, then you can finish the column drawing. Click this select icon to come up to the select mode. Here we have to replicate all these columns to the other grids, otherwise we have to draw one by one in other grids also. So it is easy to replicate, so we will select all these columns and go to edit, replicate, and as you can see there are 3 more grids. The spacing is 8 meters along y-axis, and remember this direction is y positive, this direction is x positive, so dy is plus 8 if you are going along y negative direction, you have to put -8 here. In this situation here the +8 is okay. The increment data as a number is, we need 3 more grids to complete columns, so number is 3, and you click OK. The columns will be drawn like that. We will move to the XY plane. So XY plane, when Z is 0, we are in the base level, so we have to move to the Z equal to 3 meter level, that is L1, level 1. So for that we have to click this the arrow, and you can see here the Z value is changing. It is now is equal to 3. If you click again downward arrow, here comes Z equal to 0. Okay, so we will move to the level 1, Z equals to 3 meter. Then we will draw the beams as we need. So we have to first select the section type. Beam type is 600 by 400. We now click here like this, click here, and click here, and right click, because you can't remove your mouse pointer from here. So once you right click, you have to redraw beams one by one, or otherwise you can do replicate. So you have to go to edit, replicate. Here the y dimension is -8, because we are going to y negative direction here. So number of increments are 3. Likewise you can draw the beams. Again you select the same beam size in these grids also. You can draw like this. Right click, click on the cursor icon, then again you have to replicate after selecting this to draw other beams. Okay, go to edit, replicate. Here the X dimension also 8 in the positive direction. The number of increments are 4. Okay, now we have drawn all the beams. Now we have to move to draw the slabs. I think we don't have defined the slab section, so we go to section properties, area section. So we will select section type is shell type, and add new section. Rename the slab as S150. So here we use shell thin for the slab because the thickness is around 150. So if the thickness is higher, like a pile cap or raft, you can use shell thick, but here we use shell thin. The membrane thickness is 0.15. The bending thickness is also 0.15, but the shell member is comprised of both membrane and bending, so that's why we use both membrane thickness and the bending thickness use same thickness. So the material name we use grade 30 concrete. You have to remember to change this material name, otherwise the model will be wrong. So click OK here. So we have defined the slab section. Okay, so we have to draw this rectangular area like this, because here section type is the one which we have defined. So we will click here, and click here, and so you can't see the slab here, no? Then what you can do is you can click here, but as you can see the slab is there, but there is no fill of this is not a filled of object. So to do that, you have to go here, the set display options, click here, go to general options, and you can tick on fill objects. Now you can see the slab has drawn like that. You can draw the other slabs also. And like that you have now drawn the slab along this grids. Then if you need, you can draw all the other slabs individually, or otherwise you can use the replicate option. Go to edit, replicate, dy value is taken as -8, increment value is 2 because we need to fill these two grids. Okay, click OK. Fine, we have now drawn the slabs along level 1, and then we have to define the load patterns. Define load patterns. The self weight of the members is here, dead load. The self weight multiplier is 1. We have to, this is already here, so we have to add superimpose dead load. Self weight multiplier is 0 because we normally give the value for the superimposed dead load. So we will add this, and we also need to define live load also. Load type is live, multiplier is 0. So we will define the loads like this, and since we need to add superimposed dead load to the slabs, we select all the slabs, assign area loads, we go to uniform shell, and the load pattern will be superimposed dead load. The load direction is gravity, that's downward direction. We will apply the uniform load as 3 kN per square meter, the superimposed dead load. This is the assumed value, so you can use the more correct value for your designs. Again, we will select the slab again, like this, and we will add live load using the same method, area loads, uniform shell. We will take the live load as 5 kN per square meter, we will assume that, and load direction is gravity. So we have now applied both these live load and superimposed dead load into the slab. So if you need to check whether your loads are applied to this slab, you can simply right click on this, go to loads here. You can see that both of the loads which you have applied is already applied to the slab. Okay, so if these numbers are a bit difficult to deal with, so you can hide them by clicking here. So it's clear, so now you can easily work. And also you can add a superimposed dead load into the perimeter beams. As you can see, you can click all these beams, along all these beams, which is to select the beams, and you can apply a frame load into these beams using assign frame loads distributed. Load pattern will be superimposed dead load. The load direction is gravity, and we will apply assumed load of 10 kN per meter. It is a uniform load. These things are not need, because this is a uniform load, it is not a trapezoidal load. So click OK. So as you can see, the loads get applied along the perimeter beams. Okay, now then we have to, because this slab has 8 meter bay, so to get more fine result we do meshing. So we can do this 1 by 1 mesh using, because this is 8 meter, this side is also 8 meter. So if we divided this into 8 into 8, so we can take the mesh size as 1 meter by 1 meter. So this kind of a building, this kind of a small building, this mesh size is enough to get accurate result. So 1 by 1 mesh is enough at the moment. So we will do the meshing by going to edit tab, edit areas, divide areas along the edge. Because the dimension is 8 meters, you can, if you need to divide it into 8 parts, you put here 8. The side also same dimension, we will keep here 8. As you can see, the mesh comes here. So now you have applied loads to the slabs and the perimeter beams, and what you can do is, there are 2 other floors remaining, so you can replicate all these columns, slabs and beams into other floors, then you can easily finish the model. So you can select this like this, and to edit, replicate, UDZ value is 3, and there are 2 number of floors, so the number is 2. You can click OK. As you can see, the other 2 floors also get drawn. So let me to go to general option here. You can use fill objects. As you can see, the slabs in all 3 floors are drawn here. So now the next step is to define load combination. For that, we will go here, define load combination, add new combo, combination 1. For the we will define the combination 1 as the service bit limit state. So the dead load factor is 1. We will add this here. Superimposed dead load also, the factor is 1, and the live load, so the factor is 1. So this is the combination 1. We will add another combination for the ultimate limit state. So be careful to select the dead load, not the combination 1. Dead load, the factor is 1.4. So going for state dot 1.4 and the live load fact is 1.6. So like that we can define the combinations. So both the combination defined, and the other thing what we have to do is we have to click here, and we can see that the supports we don't. So here there's a connection between the column base and the soil, so we have to define the support. To do that we have to go to the base level by clicking this arrow here. The Z equal to 0 level, as you can see the blue color is at the base level, so that window is active. So you can select all the column locations by dragging along this window. So the column locations got selected, so you have to go to the assign joint restraint, you have to select pin support because this is not fully fixed. If you fully fix the all translation and rotation will be fixed, but here we cannot idealize that, so we will use the pin support. We click on pin support and click OK. Then as you can see here, there's pin support get applied. So we have finished the model. So the next step is to run the model. For that we have to go to the analyze, see the set analyze option, because this is a 3D frame, so there are 6 degrees of freedom. So if it's the 2D frame, there are 3 degrees of freedom, so we will add 3D frame, and we will move to the run analysis icon, click here, we will run the model, and okay, we will save the model as M2. Remember to save each and every step when you are modeling, otherwise your model, when there is an issue, when there is a problem in the model, if you are going to save the model at the end, you may not be able to use the model again because of the errors. So if you save step by step, when there is issue in one step, you can use the save one earlier for other steps, because rather than waiting at the end, you can save this model in steps that you are completing. So when you draw one flow, you can save the model. When you draw the second flow, you can save the model like that. When you apply the loads, you can save another file. So like that you can save the model in various steps. That is good. Otherwise if the model have an issue, after that you cannot use the model, so you have to do the whole work again. So that's why I ask you to save the model by each and every step. Okay, So once we give the run analysis, so the model is running here. Okay, if that step is not clear, we will here when the model run, the model is locked. So if we want to do any change, we have to unlock this model. So the SAP 2000 give a message. So unlocking the model will delete the analysis result. Yes, okay. So we can do the analysis again and we can get the result. It's okay. Then we will move here again, run analysis, run now. When you are running this model, you have to carefully observe that if there are any errors or warnings. If there are errors or warnings, there is an issue in the model. So there is no errors or warning in our model. So you can see the deformed shape, and okay, you can go here. You can see the combination 2 and click OK. You can see the deform shape. Okay, and if you need to see the result, you have to go here, frame cable section. If you want to know about the moment in the columns or the beams, you can click one of this moment 22 for the axial force. Click OK. You can see the value of the moment here. To see more clear picture, you have to go for the Accessor View. Then you can simply right click on here. Then you get the diagram for the frame object. You can see the forces and the moment. So it is very easy for you to find out what are the moments and shear forces. And if it is a column, you can find the axial forces. Here you click axial force. As you can see, you need to know the axial forces. You can right click here. You can see the maximum value is 2303 kilonewton. So likewise, you can have an idea by applying loads and analyzing this model, run this model. So rather than discussing the menu and the items, it is better to do a simple example and introduce what are the functions in here. Otherwise this lecture or the tutorial will be boring. So that's why I use this simple model to analyze. So if you have any question, any other things to clarify, you can comment at the below of this video, so I may answer whatever you ask relevant to this model. So or anything about the SAP 2000 you can ask. So hope you have get more knowledge, you have updated your knowledge about SAP 2000. So hope you enjoy this tutorials. Thank you for watching. Thank you for being here for this period with me and this tutorial session. So we will meet next again with another tutorial about SAP 2000. Until then, goodbye.